Hello everybody. Alright, here we have the hard integral of 25th May 2026. Let's get into it. Here we have the integral. So we see the minimum function of three trigonometric functions over the limits of the interval from 3 pi over 4 to 5 pi over 4. So let's see how we can tackle this. So we could try referring to the unit circle, which should tell us which functions are positive and negative, since the interval is from the middle of the second quadrant to the middle of the third quadrant. The unit circle should provide us with most of the information that we need. So this is the interval that we're looking at. Let's get into it. Here we have the unit circle. So I'm just gonna focus on the interval that we have. So this, let's just label some points. So we have the lower bound of our interval, which is 3 pi over 4, the middle of our interval, or on the x-axis, the pi, and at the end, the upper bound of our interval should be 5 pi over 4. Okay, now let's split this into two sections, the one in the second quadrant and the section in the third quadrant. Alright, let's focus on the green part. If we look at this, we see that sine theta is positive in the second quadrant and the other trig functions are negative. So there's no way sine theta will be the minimum of the functions. So we can eliminate that from our guess. We do not know if cosine theta or tangent theta is the minimum in the quadrant, because at theta equals to 3 pi over 4, cosine is cosine is smaller than tangent, if I'm not wrong. And at, oh no, tangent is smaller than cosine. And at theta equals to pi, and cosine is larger than theta. So let's just leave that for later. Now let's focus on the blue part. Tangent is positive, so there's no way it is the minimum, so we can eliminate that. Now we have to look at sine and cosine. It is possible or more intuitive to know that, it should be intuitive to see that sine theta will be larger than cosine theta from pi to 5 pi over 4, because they'll only be equal to each other at 5 pi over 4, and sine theta is already more than cosine theta at theta equals pi, so we should be able to eliminate sine theta as the minimum function. So that leaves us with just cosine theta as the minimum function, as the function in the minimum value from pi to 5 pi over 4. Let's put this into an integral. So we're going to split the integral from 3 pi over 4 to pi, and the integral from pi to 5 pi over 4, so that we can tackle them separately. Now we split the integral, so we have this. And we see that the second integral is just a very easy integral to integrate, so we'll just do that. Just integrate this, which should give us a value of negative 1 over square root of 2. Now let's look at this minimum function right here. It is possible to know that tangent x will at some point be larger than cosine x from 3 pi over 4 to pi, given that we see a difference of values from 3 pi over 4 to pi. Yeah, as from the example shown before. So let's see at what value they'll be equal to each other, so that we know at what point tangent x becomes larger than cosine x. So we can do this by forming the equation cosine x equals to tangent x. Now we solve for this equation by multiplying both sides by cosine x and using Pythagorean identity to turn this into a quadratic equation in sine x. Now using the quadratic formula, we can get this, which we can simplify to become this. Now we will reject the negative 5, because that will make the sine value smaller than -1, which is impossible. So we'll simply take the positive root 5. Now, this x is simply just pi minus the inverse sine of this value right here. It's not directly the inverse sine of this value because that will mean that x is in the first quadrant, which is not possible. We are looking at the third quadrant. Yeah. This is for the second quadrant, so it should be pi minus the basic angle. Let's move on. Let's take alpha as this constant right here. So we see that before alpha, tangent x is smaller than cosine x. So that would be the minimum, the function with the minimum value over this interval. And as for after alpha, so x is larger than alpha and less than pi, cosine x should be smaller than tangent x. So that will be the function with the minimum value. Now let's put this into our integral. So we further split this minimum function right here into two integrals, which will make the functions easy to integrate. So tangent x is simply just ln of secant x, and cosine x is simply just sine x after integration. Now we plug in our values. We should get this. Further simplifying, you get this. And plug in the value of alpha. This should be your final expression. It's not a very nice expression in my opinion. But if you're too lazy to compute this, it's about -1.43 to 2 decimal places. Okay, yeah, that's the answer. Thanks for watching.